My name is Vikas Tank and I am discussing the physics paper on behalf of Prerna classes. Okay. The first paper, I am starting off with the integer type questions. The first question dealt with a bullet being fired vertically up, reaching to a height where the acceleration due to gravity is 1/4 of that on the surface of the planet. Clearly that tells us then that the distance from the center of the earth it has reached is going to be twice the radius, since the value of g is inversely proportional to 1 by r square. If I'm then looking in terms of energy conservation, the equations that I would have would be this for the bullet that was fired, whereas if I consider for the escape velocity, I can then say that this quantity should be equal to half mv escape velocity squared, which as per the given question is if we then were to compare both these equations, we simply get n equal to 2. That is then the answer to the first question. Okay. The second question talks about two uniform disks which roll down without slipping along two inclined planes to reach a lower level. We know that when a body is rotating and moving ahead, it is going to have rotational and translational kinetic energy. Again, if I apply energy conservation, then the kind of equation I would have is this for the first body, and a similar equation for the second body would become since you're told that the final velocities in both the cases are equal, just taking the differences of both these equations and using the value of v1 that is given, we get that v2 is 7 meters per second. That is then the answer to the second question. Two spherical stars which are emitting radiation. We know as per Stephen's law that the power radiated turns out to be proportional to the surface area and temperature to the power of 4. For a spherical body, area I can say is going to be proportional to r square, and if I use Bain's displacement law, the temperature is inversely proportional to lambda. So this is the equation we get, from which then we can directly write the equation that this ratio 10 to the power of 4 should be equal to the radius square, that is this, into 1 by n to the power of 4, where n is the value that we need to compute. This gives us then the value of n as equal to 2. Okay. The fourth question was straightforward. We are looking at a nuclear power plant which is supplying electrical energy. We know that in a half-life, the activity or the power production would become half. Since we want it to become 12.5%, we can simply say that 12.5 by 100 should be equal to half to the power of n, which gives us the value of n as 3. Okay. That's the answer to the fourth question. Okay. The fifth question, we are having two slits, one in air, the other in water, and we are looking for points at which there is constructive interference taking place. We know that for constructive interference, the path difference, that is in this particular case the optical path difference, needs to be an integral multiple of lambda. Now if I consider the path length in air, that is simply going to be given by this expression. Okay. The path length in water is going to be the same as this, but the optical path length would become mu times larger. So the path difference that we get then is going to be this quantity, which as per the given statement needs to be a multiple of lambda. If we take that as m lambda, we can transform this to an equation like x square is equal to 3m lambda whole square minus b square, which gives us the value of p as 3. And a concave and a convex mirror, that is this kind of setup. Firstly, the object was located here. That distance was given to us as 15. The focal length of this was 10. It's simple to compute then that the image here is going to be formed at a distance of 30 centimeters, which means then that is going to behave as an object for this lens at a distance of 20 centimeters. Clearly, whether the surrounding medium here is air or liquid, the image formed by the concave mirror is going to be at the same location, same magnification. Since we are looking for the ratio of the magnifications, that would simply be the ratio of the magnifications produced by this lens. For a lens, we know that the magnification produced is going to be given by f by u minus f. So in the first case, when this was in air, the focal length of this is 10, which would then give you the magnification due to the lens in the first case as 1. In the second case, when that surrounding medium is some other medium, we know that the focal length mu1 can then be written as mu minus 1 into f by the relative mu minus 1. This then turns out to be 17.5 centimeters. And therefore, the magnification in the second case, again using that same formula, is going to be 7. Clearly, therefore, the ratio of the two magnifications then is going to be m2 to m1. That is 7 as the answer to this question. Okay. The next question, we were looking at the flux which passes through a rectangular area due to an infinitely long wire. Okay. Now, if I were to assume that there is an infinitely long wire here, and I have a rectangular area like this, I can simply say that if I were to consider a cylinder whose axis is this, and that cylindrical surface passes through this, the flux through this would be the same. Clearly now, since this vertical height has been given to us as root 3a by 2, whereas this distance has been given as a by 2, if I consider this arc, the angle it would be subtending at this axis is going to be twice tan inverse of a by 2 by root 3 a by 2, okay, which then is turning out to be pi by 3. I know that the flux associated with a complete angle of 2 pi would have been, by Gauss law, lambda L by epsilon naught. Therefore, the flux associated with an angle of pi by 3 is going to be lambda L by 6 epsilon naught. That would then give you the value of n as 6. Okay. The line in integer type, you had a 90 nanometer wavelength photon being incident on an electron already in an excited state. Now 90 nanometer we can easily transform in terms of energy. That comes out to be 13.8 electron volts. This energy is going to be equal to the binding energy that it has in the nth state plus the kinetic energy acquired by the electron, which has been given to us as 10.4 electron volts. Clearly that tells us then that the binding energy in the nth shell is 3.4 electron volts. If I compare that with 13.6 by n square, we get the value of n as equal to 2. To the second section, that is multiple correct options. The first question there talked about a container of fixed volume containing 1 mole of hydrogen and 1 mole of helium. Okay. The first part that you're looking for was the average kinetic energy, average energy per mole of the gas mixture. We know that the energy for 1 mole of a gas mixture is going to be the degrees of freedom into R into T by 2. We also know that for hydrogen, the degrees of freedom would become 5, and for helium, the degrees of freedom would become 3. In other words, the average number of degrees of freedom is 4, and therefore the energy then is going to be 4RT by 2, that is 2RT. Hence, option A is correct. The next one was looking at the ratio of the speed of sound in the gas mixture to that in helium gas. We know that the speed of sound is given by root of gamma RT by m. That is, it's proportional to root of gamma by m. Gamma we know is going to be related to the degrees of freedom as degrees of freedom plus 2 by the degrees of freedom. So for that mixture, gamma is going to be 3 by 2. The molar mass of that mixture, we know that hydrogen has 2, helium has 4, then is going to be 3. Whereas gamma for helium, we know is 5 by 3. The molar mass of helium is 4. So the ratio that we are looking at then is going to become this. So option B is also correct. The third option, or the third part that we are looking at, is the RMS speed of helium atom and hydrogen molecules. We know that the RMS speed is given by root 3 RT by m, that is, it's proportional to 1 by root m. Since the molar mass of hydrogen is going to be 2 and that of helium is 4, the ratio that we are looking at then is going to be 1 by root of 4 by 2, that is 1 by root 2. Hence, option D is going to be correct. So the correct answer for this section then is going to be A, B, D. The next question, we are looking at an aluminum bar in which there is a central iron section, and you are required to figure out the electrical resistance between the two end faces. Clearly in this case, there can be a current flow through the iron section or through the aluminum section. In other words, those two resistances are going to be in parallel. We know that the resistance of a rectangular section is going to be given by rho L by A. So if I were to consider the resistance of the aluminum section, that would become, since the units are in micro ohms, I am dealing with micro ohms there, 2.7 into 10 to the power of minus 8, length is 50, and the cross-sectional area I can say is 49 minus 4 millimeters square. That is then going to give me a term like this. That would be the resistance in ohms, and since I want the resistance in micro ohms, I need to have this much. Okay. This, if you consider, turns out to be 30 micro ohms. Similarly, if we look at the resistance of the iron section, that is going to be which turns out to be 1250 micro ohms. Okay. Since both of these are in parallel, the equivalent we can say is going to be these many micro ohms, and therefore the answer for this section is going to be B. Dealt with the graph of the stopping potential versus lambda or 1 by lambda. Now we know that for photoelectric emission to take place, lambda needs to be less than a certain cutoff wavelength, and as I reduce the value of lambda, the energy is inversely proportional to 1 by lambda, and that would then keep on increasing. Clearly then the graph that I would have for V0 versus lambda is not going to be a linear graph. That graph will exist only for lambda less than the cutoff one and would appear like this, which is the graph that we have in option A. Similarly, if I consider the graph of V versus 1 by lambda, that graph will turn out to be like this. So the correct answer for this is going to be A and C. The next question dealt with the vernier caliper and the screw gauge. For the vernier caliper, you are given that a main scale division is equal to 1 centimeter. Since 5 vernier scale divisions are coinciding with 4 main scale divisions, we get that a vernier scale division is going to be 0.8 centimeters, and therefore the least count of this is going to be 0.2 centimeters or 2 millimeters. As far as the screw gauge is concerned, based on the information given, I can simply say that the least count of that screw gauge is going to be equal to the pitch by 100 circular scale divisions, which is then also equal to 2 main divisions by 100. For the various options then, what you have been told is that twice of this quantity. Okay, the next question dealt with photoelectric effect, in which we are looking for the stopping potential in terms of the wavelength of the incident light. We know that the energy of a photon is going to be given by this. Provided that wavelength is less than the stopping potential, cutoff wavelength, we can then say that this minus the work function should be the electronic charge into the stopping potential. Clearly from this we can see that V versus 1 by lambda is going to be a linear graph with a positive slope, and correspondingly the graph of V versus lambda is going to be like a rectangular hyperbola. Therefore the correct answer for this section would become A and C. The next question dealt with vernier caliper and screw gauge. From the information given, we get that one main scale division of the vernier caliper is going to be 1 by 8 centimeter. One vernier scale division is 4/5 of a main scale division, which then turns out to be 1/10 of a centimeter, and therefore the least count that we are getting, the difference of both of this, is 1/40th of a centimeter. This is the information that we have for the vernier caliper. If we consider for the screw gauge, as per the information given, what we obtain is that the least count of it would be equal to the pitch divided by the number of divisions on the circular scale, which is 100. That also turns out to be equal to 2 main scale readings by 100. For the various parts now, you have been given that twice of this least count is going to be equal to either this pitch or this. Accordingly then we can easily compute what the correct answers would turn out to be. They will come out to be B and C. The next question was on dimensional analysis, wherein you were required to find out mass and length in terms of Planck's constant, speed of light and gravitational constant. We know that Planck's constant is going to become this, speed of light is dimensionally this, and the gravitational constant is. If you look at this, I can then directly say that m square is going to be equal to hc by g. And if I look at the ratio of both of these, I get that ml is going to be h by c, equivalently giving me that length dimensionally is going to be root of hg by c to the power of 3 by 2. If you then were to compare this with what are the various options provided, we get that the correct answer for this is going to be A, C, D. The next question dealt with 2 independent harmonic oscillators, some information provided about their momentum, etc. For the second particle, what we are getting is that the maximum value of the momentum is equal to R. We also know that the maximum momentum has to be equal to m into V maximum. V maximum I can write as omega into the amplitude, that is R. So therefore I get that m omega 2 should be equal to 1. As far as the first one is concerned, you have been given the information that A is equal to nr, B from which turns out to be R by N. So this B is again going to be m into omega 1 into nr, which gives us the equation that m omega 1 square is going to be equal to m omega 1 into n square is going to be equal to 1. Comparison of both of this directly gives us that omega 2 by omega 1 is going to be n square, which is what we had as option B. Additionally, if you are looking at now energy, the ratio of these two energies, I can say is going to be omega 1 square into A square is to omega 2 square into R square, which is then omega 1 square n square by omega 2 square, And if I use n square as omega 2 by omega 1, this is then turning out to be omega 1 by omega 2. That was option D. So the correct answer here then is BD. Dealt with a ring with 2 point masses. The point masses are at the center. That ring was said rotating. Sometime later the point masses are at some other locations. All we need to apply here is going to be conservation of angular momentum. So if we consider initially the angular momentum, that is simply going to be mr square. Due to the 2 point masses, that is 0. And you have an initial angular velocity of omega. This should be equal to the final angular momentum, which is mr square for the ring. Then m by 8 into 3r by 5 whole square for the first point mass. And let's say the other point mass is at a distance x, then x square. And then the omega you have been given turns out to be 8 by 9 times omega. There's a straightforward equation to solve from which we get that x is equal to 4r by 5, which is option D. The next question dealt with two infinitely long wires like this with linear charge density lambda and a point charge which is constrained to move along the x-axis. We know that due to an infinitely long wire, at a point here the electric intensity is going to be directed this way, and that is going to be inversely proportional to x. Clearly then, if this I consider a point here, the electric intensity at this point due to this lambda is going to be greater as compared to this, and therefore the net electric intensity is going to be this way. In other words, if this were to be a positive charge, it will experience a force this way and perform SHM. If it's a negative charge, it will simply move along the direction it's displaced, thereby giving you the answer as C. The next question dealt with two glass rods having one convex end each facing one another. You are required to figure out the separation between the two rods so that you end up getting a parallel beam of light from this. That is the setup that we're having is this. Let's say the image of this source is formed at this point, this distance being x. The radius of curvature of this was given to us as 10. The equation that would then be having in such a case, I would simply write it as this. As far as the second rod is concerned, that is where we have what we are having now. If I look at this distance being y, we require a parallel beam of light to be going here, from which the equation that would be getting is just going to be that y is 20. Clearly then that distance d, which is going to be x plus y, turns out to be 70, which is the answer B. The last question in this section dealt with a conductor given a shape comprising of certain line segments and arcs. We know that for any arbitrarily shaped conductor placed in a uniform magnetic field, the force simply depends on the distance between the two endpoints. In other words, then I can say that the force is going to be given by I, the length of that which is going to be 2L plus 2R along the I vector cross B. That is the expression that we'll have for the force. Obviously then, as long as B is not along the x-axis, there is going to be a force which is proportional to L plus R. If B is along the x-axis, then the force is going to be 0. The answer therefore for this is going to be ABC. Going on to the third section, the matrix match one. The question dealing with nuclear processes. A nuclear fusion process is one in which lighter molecules combine to give a heavier molecule. That in this particular case is going to be option R. Okay. So for A, it is R. For B, we are looking at fission taking place in a nuclear reactor. In such a case, a heavy nucleus absorbs a lighter particle or a neutron and breaks up into two nuclei. Such a thing takes place in the absorption of thermal neutron by uranium-235. Heavy water is used as a moderator for such a thing, so that is also going to be part of the answer. The next one is beta decay. Beta decay takes place in cobalt-60 nucleus, so option Q is going to be correct. This would also be leading to the emission of a neutrino, so option T will also come out to be correct for this. The final option which we are looking at is gamma ray emission. Gamma ray emission would come about when we are having decays taking place in a cobalt nucleus, as well as when we are looking at a fusion reaction coming about, so Q and R. The last question there, we're dealing with a unit mass constraint to move along the x-axis. Potential energy function was given in various cases, and you're required to figure out what happens, that is what is the equivalent position, whether the particle experiences the attractive force toward the origin and whether it can oscillate or not. Basically what we need to consider here is how does the potential energy graph look like. In the first case, the potential energy expression is given as this, the graph of which then is going to be of this form. The force we know is going to be the rate of change of the potential energy. So if there is a local maxima or minima, then the force is going to be zero. Clearly that happens at these 3 points. So P, Q and R are correct. As far as S and T is concerned, around this point if I displace the particle, the energy reduces. Obviously then there is not going to be an attractive force towards x equal to 0. Whereas if I consider the particle located here, I know that this value turns out to be U0 by 2. If the total energy at this point is U0 by 4, that energy is insufficient for the particle to reach here, and therefore option T is also going to be correct. So we get P, Q, R and T as the correct answer for the first one. For the second one, the potential energy expression was given as U0 by 2 x by a whole square, the graph of which is going to be this, which is what we have normally as the SHM case. The correct answer for this then is going to be Q and S. For the third option, the potential energy was given as this. Once again, we can easily see that the potential energy is going to be 0 at the origin, and as I increase the value of x on either side, the potential energy increases. Due to that exponential term that's going to later on reduce, the graph that we get is then of this type. Okay. So what we find again is that there is equilibrium at each of these 3 places, that is P, Q, R are correct. Additionally, x equal to 0 is the point of minimum potential energy, so option S is also going to be correct. That is for the third option. Fourth option, you had been given the potential energy as U0 by 2 x by a minus x by a whole cube. That is like the graph of a cubic function with a negative coefficient of x cube. That graph then will turn out to be of this type. Okay. Clearly we can see then that the minimum potential energy occurs at x equal to minus a, maximum at x equal to plus a. This is not a local extrema. So the correct answer for equilibrium points is going to be P and R. Okay. There is no question of an attractive force toward the origin in this region. For positive x, there's an attractive force. For a negative x, there's going to be a repulsive force. Again, the energy that you would be getting at this point by putting x equal to a, we find that is turning out to be U0 by 3, which is greater than the total energy that's been provided at this point. In other words, the particle here will not be able to cross this, and therefore it would oscillate about that point. So PRT would be the correct answer for that.